Hello everyone and welcome back. So now we're going to start looking at the fire sourcing and get the setup going. And if I wanted to show the fire sim here, and if we look closer, it all starts at the same time at frame 80, and that's when the impacts, the lightning happens as well. The what would have been better is to have the fire actually start coming in slowly over time, maybe over 15 frames. But I used that moment because I know it's going to be impactful and to introduce this element as well all of a sudden. Now I blended it in with some comp treatment to have the crack show up slowly, and then boom, everything happens. And the emission, everything for the emission of the fire starts at the same time. If you want to explore using a longer period for emission and having it slowly start, or using a noise to emit that, that's perfectly fine. For me, I just used one frame because I know it's going to be enough for this case. So the first thing we need is, well, let's take a look at the shot. So maybe not this one. Let's take a look at the close-up one. Yeah, so the first thing we need is the source. And if we look at it here, you will see that the fire, if the gap closes in that geometry, it fades. See, it's still coming, but it's not making it all the way through. And here, because we have a huge gap, we have a lot more fire coming off. Basically, whenever we have a gap, it's going to emit. And there's many ways that we could go about creating this source. But what I've done, or what I ended up using, is to pick a frame after and then analyze how much cracks I have in that frame compared to the original frame. Okay, and then use those cracks at frame 80 to be the source. And on top of that, even if it's going to be covering an entire area, I'm going to place the collision on top of it. Okay, and the collision geometry has to be really high res. And this is simulating like as if it was in real life. You have a layer underneath that is emitting fire, and then on top of it is the collision. So that's why we're getting these nice wrapping around the fire, and it's only escaping where it makes sense. For example, look at this area here. Look at this area. If I go through, you will see the fire escapes from that crack and then stops. And it's coming from here. And that's realistic because that's how the source is working. Now, if we were to use a dynamic sourcing, it's gonna be, the fire is gonna be always following the cracks. We're not gonna get this nice, escape and then stop, escape and then stop based on the geometry. And that's what I personally wanted. So I just needed to pick a frame where I have plenty of cracks, or where frame 80 basically, and then use that to be the source for the remaining of the sim, and then have the collision on top of it be dynamic. So I'm gonna go over the setup because it's very self-explanatory. I'm not gonna rebuild it from scratch. And the first thing that we need is this. Okay, we need the main sim. Now, another quick thing that I did was to retime. I believe, no, I didn't retime it. Never mind. At one point I was retiming the RBD sim, but I didn't do that. Okay, so this is the source, and that's the main thing we need. We need the geometry, and we need to have it deforming. And then I use the debris source, same thing that we used before, and these are the settings. The emission starts at frame 60. That's after the ground collapses. So around here, because I didn't care about what's going to happen before that. So at frame 60, it's going to use that as a rest frame and then compare what has changed versus this frame, or compare it against this frame. And so these are the settings. The separation distance multiplier is 3. The velocity threshold is 0.1. The min life is about 3 frames. sorry, about 50 frames, and then the max life is 125. And I used a lot of points, search radius of 1, search points 50, and this is the result. So these are the points that matches the RBD sim. And then I used a long distance because I wanted those points to emit for for maybe 20 frames or something like that, so that I have enough sourcing. And my idea was that this source is going to be the same for the smoke as well as the fire. It's just that the fire is going to happen only one frame. It's going to be consistent. But later I also wanted to use this for the smoke sourcing, so I wanted to make sure that I have enough time for the smoke trail to be visible. If we leave it on for too long, then these pieces are going to be emitting all the way through, and that's not realistic because the debris accumulated on one piece is, it can cover only certain distance, and then it's material stuck on it, and then it's gonna fade off eventually. Everything is gonna be emitted, and that piece will be a unique a standalone thing that doesn't have any extra stuff on top of it. So everything has gone already. So that's the source cached, and then I'm gonna use velocity as always. So I don't care about things that are moving slow. I use the velocity to isolate that. And I blast everything that does move between this region, or this range. Sorry. So here between 0 and 60. And then I delete everything. And then the next thing I always do is, I think a lot of you guys know this already, for the emission, I don't emit where the geometry is pointing at. So I have this piece, okay? I don't need the debris to be coming off of this from the front. I only need the debris to coming from the back. So if the geometry rotates, I always need to make sure that it emits from the back. The easiest way to get that information is by comparing the dot product with the velocity. So if I display both, you'll see this angle here, this velocity vector. If I do the cross product, they are facing away from each other. So I'm going to ignore that. If they're aligned on top of each other, if the velocity is aligned with the normal, like this, they're somewhat aligned, I'm going to keep that. Okay, so this is the velocity. Sorry. This is the mask I create. Let's see these points. Ignore the velocity. So these points are going to be kept, and then everything else is going to be deleted. And if I step through, we will see that changes dynamically as the object rotates. And this is very, very simple way to make sure you don't get smoke in front of the pieces. And then I delete all the points that I don't need them. Okay, so I always get a trail from the back. Now what I also did is this velocity mixing. And what I did is I mixed in the normals with the velocity. So I didn't want the smoke to be only coming from this way. I also wanted to include some of the geometry orientation. This may not make a lot of sense, but I wanted to have some force pushing outward no matter what the geometry is. Otherwise we get, like if we emit from this, we're gonna get a straight line. If we add the normals as it rotates, it's gonna add some padding to it. So that's what this does. I normalize the normal, make sure it's normalized. I normalize the velocity, and I mix both of them. So if we take a look at this, and this is my original velocity, and this is my normal. Yeah, it's not very visible, but it's there. And then if I mix both of them after normalizing them, let's put a multiplier so it's easier to see. If I mix both of them, then I'm gonna get, the geometry normals mixed in with the velocity, but then I don't want to change the velocity magnitude. Okay, so what I do is I take that result, normalize it, and then multiply it back by the length of the velocity itself. So the magnitude of the velocity is not going to change, just the orientation of the vector is going to change. And I'm mixing in 50% of the velocity and the normals. And the other part is for doing the dot product, and I'm using -1 and 0.5 or 0.6 basically to isolate only this area here. And anything that is not overlapping, any vector that are pointing away from each other, they're going to be excluded. Okay, then a time blend, and with this we have to make sure that we have an ID. Do we have an ID? Yeah, so this sim, after the debris source, it always creates an ID, and that's very, very important to the next step. Like you guys saw in the previous quick test we did with the smoke solver, the sphere was creating steps. You know, it doesn't matter. We have to increase the sub-steps quite a bit to fix that trail and get a continuous result. We don't want that. So my solution is in SOPs, and I think by now all of you guys know my workflow. So what I do is I make sure that my points have an ID, and then I trail them over time. Okay, and oh, come on. So I trail them over time, and this is what the result looks like. Just 4 steps and an increment of 0.75. You just need to get extra length behind it. That's it. Doesn't have to be just a bit longer. It doesn't have to be too long. It depends on the sim. It depends on what kind of setup you want. And then after I trail, I use an add node to connect all of them, because they have that ID number. I can connect and create lines. Now with these lines, I will measure them, attribute promote the parameter attribute, and that gives me the length of the vectors. Now what this will allow me to do is isolate geometry that hasn't moved too much over time. Okay, so if something is still considered in the system, if it doesn't have a decent parameter in it, I'm gonna ignore it, because it doesn't make sense. And these two conditions escape the velocity, because we're checking in the previous frames, and this piece may this geometry here may have a velocity that is enough for it to keep it this frame, but the previous frames were not. So this check is basically to make sure that everything we have is moving, or is going to be, yeah, it's moving. It makes sense to use it. So then I delete based on the length of these curves. Okay, so just measure parameter and then attribute promote so that it's a pointer attribute, and then I delete. Okay, so the next thing is we need to convert this into a volume. And right now we don't have a lot of points. So what I do, or we do have, so I just resample to make sure that I have a uniform distribution. Sometimes I increase the number of points, and then I compute the length, or the UV coordinate along the U, so I can get a gradient that looks like this along each curve. Okay, cool. So the next thing is I set up a p-scale attribute that is equal to the color plus 0.05 in this case, and that way I get I can have when I convert this into a volume, or if I copy spheres to it, the spheres are going to be wide at the in this area, and then fade off or get thinner along the length of the curve. And I added some attribute noise for the velocity just to randomize it, and then I rasterize everything. So for the volume rasterization, I'm rasterizing 2 attributes, density and velocity, and I'm also using this velocity attribute which stretches the density field. Now what we're looking at here is the velocity field and the density field. Velocity field doesn't have a nice padding because it's a vector and it's hard to see, so I simply hide it. Okay, and this is my, let me hide everything, and this is my volume. And you can see the tip are thinner I could have increased, let's do that. I could have increased the detail of the volume, but 0.2 was enough for what I was looking for. And then I use the volume compress to optimize the velocity field, just to make sure that when I cache it, it doesn't take up a huge amount of space. And then I ticked on both of these and set up a value of quantization of 0.05. And then 16 float. This will just reduce the velocity field disk space usage. And then I cached it to disk, and this is what it will, and this is what it looks like. So this is my source, and then it dissipates quickly, it fades off, and then I have the center as well. So pretty much everything included here. And that's it. That's it for the source creation. I'm gonna still process it a bit more in the next phase, because what I needed is a source that works with everything, but then I had to customize it per effects, like for the fire, and then for the volume I need to split it and stuff like that. So we're gonna do some processing afterward to get this ready for the fire emission. But this is the main graph for creating the source, and this setup has been very, production ready, and it always works. So cool. Thank you guys for watching, and see you in the next video. Bye bye.